Hello, students. Am I live? One second. Okay, I'm live. Hello, welcome all of you to another session of Vedantu Karnataka. This is Catherine, your physics master teacher. I can see a lot of messages in the chat saying, I'm scared, I'm way too scared. My exam is starting tomorrow. Hooked. Are you all scared for physics midterm exam? Okay, students, quickly today I'll discuss all the most important questions, okay, that you can get for your exam. Yeah, mainly 5 mark questions because that's the most important, right? All the others, you can somehow manage. Okay, are you all ready for today's class? Quickly put some fire emojis in the chat and then we'll start. Also, I'm reminding you once again, students, please don't forget to write the MVSAT. I know you're all tensed because you have your midterm, but after your midterm, please write the MVSAT also. Okay, on 11th and 12th. Okay, let's start. Ready, ready, ready? Hello, Sunena. Hello, Sirik. Hello, Sakina, Alina, Bhuven, Kiriti. Hello, everybody. Okay, let's start from chapter 1. So, first question that you can most likely get is derive the expression for an electric field at a point on the axial line of an electric dipole. Okay, that's the first question you can get from the first chapter. Okay, so students, for these diagrams, for every diagram where I have put picture, it's very important to draw diagram because without the diagram, you will not get any marks. Okay, so it's very important to draw the diagram for these kinds of questions. All right, so how will you draw the diagram? This is for an electric dipole. So what is an electric dipole? You need a positive Q charge and a negative Q charge. Okay, so this is plus Q, minus Q, and they are separated by a distance of 2a. Okay, and then you take a point P. Okay, from minus Q, you take a point P. Okay, the distance between P to O, the distance between P to the center of the dipole is R. This is the diagram. Very simple diagram. Okay, and then the derivation is also very simple. Yeah, derivation is also very simple. First, I have to find out electric field because of plus Q. Then I have to find out electric field because of minus Q. What is the general formula for electric field? 1 by 4 pi epsilon naught Q by R square is the general formula. Okay. Now let's take it for plus Q first. So when I take it for plus Q, it will be 1 by 4 pi epsilon 0 Q divided by what will the distance be? What will the distance be? From point P till Q, the distance will be R plus A. Okay, students, so this diagram, it's good if you can make this diagram. You can make this minus Q and this can be plus Q. Okay, and for plus Q, what will it be? The distance from point P, it will be R minus A. Okay. Nikhil, these are all questions that are usually repeated. These are all very famous questions that come for the PU board. So not all of these questions will come for your exam, but sure, some of these questions will definitely come. Okay, these are all past year questions. And then what are you going to do? E plus and E minus, you simply add them. You take 1 by 4 pi epsilon 0 outside, you add them, you will get the answer. So 2QA, you will write it as P. That's all. Okay. It's there here. You can just go through the steps very easy. Okay. Next, derive an expression for electric field at a point on the equatorial plane. Okay. So for that also diagram is very important. Let me show you how to draw the diagram. So you take a charge minus Q here, plus Q here, and you are going to find out the electric field at a point P, which is at an equatorial position. In the previous one, P was along the line. It was at an axial position. Here, P is at an equatorial position. Okay. Now P is at a distance. So the distance between plus Q and minus Q is 2a. Okay. Now the direction of electric field. So that at point P, okay. See, for negative charges, electric field is always towards the negative charge. So this is the direction of electric field. Yeah. This is the direction of electric field. So this will be electric field. Now for plus Q, it will be away. So this is the direction of electric field for plus Q. Okay. So there is E1 along minus Q, E2 along plus Q. So both, why the directions are opposite? See, for a negative charge, electric field lines are pointing towards it. For a negative positive charge, electric field is away. Now this is the resultant electric field. Okay. Now what we are going to do is we are going to take the resultant E is equal to 2 EQ sine 90, which is 2 times EQ is 1 by 4 pi epsilon 0 Q by R square into, what is it? A by R. Okay. So this you can take it as R because in the derivation it is R. I'm getting so many messages in the chat, students. I'm not able to reply to all of those. Okay. This is not just for 5 marks, but most important questions. Okay. Ma'am, can we do like P is point on what? I didn't understand that. You can follow the blueprint as well as these questions. Okay. Okay. Next important question. Use Gauss law. Derive the expression for electric field due to an infinitely long, straight, uniformly charged wire. Okay. So you have this positive red bar that you see is a straight line of charges. Okay. So what I'm going to take is I'm going to take a Gaussian surface around this. Okay. I'm taking a Gaussian surface. And what am I going to do? I'm going to use Gauss law. So what is Gauss law? Phi is equal to electric field E into the area. Okay. So for a cylinder, it is 2 pi R L. Okay. Now Gauss law also states that phi is equal to Q by epsilon naught. Yeah. So Q by epsilon naught is equal to E into 2 pi RL. Now Q is what? The amount of charge. So let's say there are lambda charges along this positive line and the length of the line is L. So total charge will be lambda into L by epsilon naught. So now we will equate this. E2 pi RL equals lambda L by epsilon naught. Now I will equate the common terms. Any common terms? L is common, no? L is common. I will cut off L. E into 2 pi R. So E will be lambda divided by 2 pi R epsilon naught. Okay. What is this? So many messages. Akka. What is it, Akka? Okay. Next question. Derive an expression for electric field due to a uniformly charged infinite plane sheet using Gauss law. So for this one also, figure is very important. So what is a figure? So you have a sheet of charges. Okay. You have a sheet of charges, a plane sheet full of charges. And you are going to draw a Gaussian surface in the form of a cylinder through it. Okay. So you have a plain sheet of charge. This cylinder is your Gaussian surface. Okay. So one thing you need to know here is along the perpendicular line, which is like this sides. Okay. If this is your cylindrical Gaussian surface, okay. If the electric field and the area, if they're perpendicular, then they cancel out. You don't have to consider that surface. So here, the only two surfaces we're going to consider are the two sides of the cylinder. Okay. So if this is the cylinder, the two sides. So that is what I have taken. Phi is equal to EA plus EA, which is electric field into area on both the sides of the cylinder. Okay. Which all sides? This side and this side. So EA plus EA. So total electric flux will be 2EA. The flux that enters through one side and the flux that exits through the other side. Okay. So phi is equal to 2EA. What is Gauss law? Gauss law states that phi is equal to Q by F. Okay. Now here, what am I going to take charge as? So in the previous question, I took Q as lambda L. Here I'm going to take Q as sigma A. Okay. So what's the difference? There it was a line of charge. So I had to only take length. Yeah. So I'll take lambda into length. Here it's a full sheet of charge. So I'm going to take sigma into the area. Okay, students, these things you need to remember. All these I can derive and show, but it will take a lot of time. So you don't have to derive it for your exam. That's why I'm asking you to study it like that, because this is last minute revision. Okay. Yeah. So Q, I will write it as sigma A by epsilon naught. And this is also going to be equal to 2EA from the previous one. Okay. Now A and A you cancel. You will get E is equal to sigma by 2 epsilon naught. Okay. Yes. Yes, this will definitely be helpful. That's why I'm doing this. Okay. Maruti. But you will not get 50 above from this because you have MCQs, you have fill in the blanks, you have numericals. These things I'm not going to discuss here. Okay. But important questions, yes, I am going to discuss. Okay. Next question. Expression for electric field due to thin spherical shell at a point outside the shell using Gauss law. Okay. For this one also figure is important. I haven't put the figure here, but please draw the figure also. Okay. So here again same formula. Electric field is equal to 1 by 4 pi epsilon naught q by r square. Okay. 1 by 4 pi epsilon naught q by r square. Now, at the surface, you have r is equal to r. So, you just write it as E is equal to 1 by 4 pi epsilon 0 q by capital letter r square. Okay. Next, from electrical potential due to an electric dipole. Okay. So, let's consider an electric dipole with charges plus q and minus q. Okay. So, let's say you have two charges plus q minus q. Okay. So what I'm going to take is separated by a distance 2a, let the dipole center be O. No, all that is fine. So the potential at point P because of plus q will be what? 1 by 4 pi epsilon 0 q by r. Because of minus q will be 1 by 4 pi epsilon 0 minus q by r2. Okay. Now total potential will be plus q plus minus q, which is q by 4 pi epsilon 0 1 by r1 minus 1 by r2. Okay. Now by using binomial expansion, what we're going to take is 1 by r1 minus 1 by r2 is approximately equal to 2a cos theta by r square. So v will be equal to q by 4 pi epsilon 0 2a cos theta by r square. And p you can take it as q cross 2a. Okay. Next question. Derive an expression for electric potential at a point due to a point charge. Okay. So let's take a point charge Q that's going to be placed at a point O. So the electric potential V at point P at a distance R from O is defined as the work done to bring a positive unit charge from infinity to a point P. Okay. So what we're going to do, potential is minus E dr. E we already know is how much? 1 by 4 pi epsilon naught q by r square. And then I'm going to substitute that E here. So what will it become? V will be equal to 1 by 4 pi epsilon naught q by r square into dr. So q by 4 pi epsilon naught 1 by r integrating, I will get V is equal to this. Hi Ravi Chandra. Hi Shifa. Hi Maruti. Okay. Okay. Next question. Students, I'm not going to explain these in detail because I'm going to do this in like 1 hour. This is like a revision for all those who have done everything. Then this is a revision. Next question. Define capacitance of a capacitor. Arrive at the expression for capacitance of a parallel plate capacitor. Okay. So here you have to find out an equation for capacitance. So we'll start with the equation. What is a capacitor? Two plates separated by a distance d. Okay. Two plates separated by a distance d. The area of this plate and this plate both are a. So we will start by the formula. Capacitance is Q by V. Okay. Capacitance is Q by V. Now, E is equal to sigma by epsilon naught. Okay. Which is equal to what? Q by A into epsilon naught. Remember, in the previous derivation, I said Q is sigma A. That you can use here. So here, sigma will be Q by A. Same thing I'm using here. Sigma, I'll write it as Q by A. Okay. Next, I'm going to multiply D, because I'm taking voltage. So potential is what? ED. E is Q by A epsilon naught. So since I have D also, I'll put D. Okay. Now I also know that C is equal to Q by V. Okay. So if C is Q by V, then what will I write it as? Q, I will put it as Q itself. Okay. Divided by QD by A epsilon naught is V. Q and Q I cancel. All this will go up. So it will be A epsilon naught by D. Okay. Now if between the capacitors, if there's a dielectric, then you add the dielectric constant also. So it becomes K. Okay. Yes. My name is Catherine Shivu. If you're new to the channel, please subscribe to the channel. Okay. Tell all your friends about the channel. Yeah. Okay. Next question. Derive an expression for effective capacitance of a series combination of two different capacitors. Okay. So if you have two capacitors in series, yeah, you have two capacitors in series, then we have to find out the effective capacitance. Okay. So what do I have? So I need only two. So in the figure, I have to have two capacitance which are in series. So this is the capacitor C1. This is the capacitor C2. Okay. So let's say Q. Q is the charge. We already know the formula. Here, what formula did we use? C is equal to Q by V. Okay, C is equal to Q by V. So from this, I know Q is CV. Yeah, same formula I'm using here. So since I have two capacitors, for the first capacitor, both capacitors will get the same charge Q. Okay, for the first capacitor, Q will be C1V1. For the second capacitor, Q will be C2V2. Now, if you rearrange the equations, V1 will be Q by C1, V2 will be Q by C2. Now, total potential. See, this is a series circuit. In a series circuit, voltage is V1 plus V2 plus how many ever capacitance are there, you add all the voltages. So, in a series circuit, V is V1 plus V2. So, this is basically Q by C1 plus Q by C2. Okay. Now, to find out the equivalent capacitance, we say that Q is equal to C equivalent into V. Okay. So, from that, V is equal to Q by C equivalent. Okay. So, we can write Q by C equivalent is equal to, instead of V1, we will write Q by C1. V2 will write Q by C2. All the Q's cancel. You will get 1 by C equivalent is 1 by C1 plus 1 by C2. Navyasri, ma'am, I'm easily understanding. Thank you so much. No problem, Navyasri. Please send the link to all your friends. Ask them also to come and listen to the class. Okay. How many marks maximum? That I can't say, dear. It will depend on your question paper, no? Okay. Next question. Obtain the expression for effective capacitance of a parallel combination of two capacitors. So here, what is the question? You have two capacitors which are connected in parallel. Okay. We have to find out the equivalent capacitance. Same formula, Q is equal to CV. Here, what you need to know is, in the previous question, charge was the same. Yeah. For series, charge was the same. But for parallel, voltage is the same. Okay. So here, capacitor 1 has a charge of Q1, capacitor 2 has a charge of Q2, but they both have the same voltage. In series combination, they both had charge Q and Q, but V1 and V2 was voltage. Okay, so here charge is different, but voltage is the same. So how will I write my equation? I will write it in terms of charge, but V will be same, no V1, no V2. But here you will have Q1 and Q2. Okay, so Q is equal to Q1 plus Q2, which is equal to, what is Q1? C1V plus Q2 is C2V. Now, since V is the same, I'll take it outside. I'll write it as C1 plus C2, brackets, I'll put V. So, this is basically C1 plus C2 into V. Okay. Now, Q can be written as CV. So, total Q will be C equivalent into V. Okay. So, C equivalent will be Q by V, which is basically equal to what? It is basically equal to C1 plus C2. How did I get that? Because Q is equal to C1 plus C2 into V. So Q by V is equal to C1 plus C2. That's all. Okay? Yeah. These are all easy derivations. And one of this will definitely come. I don't know which one will come, but one of this will definitely come. So let's just hope all of these come. I'm not that old, Shivu, to have children and all, okay? Don't worry. I'm fine. I'm doing great. Okay? Harshi, hi. Okay. Derive an expression for electric current in terms of drift velocity and number density of free electrons. Okay? Drift velocity and number density. So very easy. First formula with respect to current. Okay? So what is the first formula? I is equal to drift velocity into time. Okay? And N is equal to NAVD into T. Okay? So we already know Q is equal to N times E, which is equal to NAVDT. And then you just substitute. You will get this answer. Very easy. Yeah? Akshay's physics exam is over. Very good, Akshay. But there are students who have physics exam tomorrow. There are students who have physics exam next week also. Okay? So this video will help them. I'm sorry that your physics exam is over, but still. This is for others. Okay, Akshay? Hi, Yadav. All of you subscribe and like. All of you go like the video, subscribe to the video. Tell all your friends to study physics from Vedantu, Karnataka. Next question. Assuming the expression for electric current, arrive at the expression for electrical conductivity of a material. Okay? So we have to assume, we have to get an expression for electrical conductivity, which is sigma. So what do? We start by J is equal to I by A, which is equal to NEVD. VD is what? EE tau by M. Okay? Now you just substitute the two, you will get this answer. J is equal to sigma. E sigma is NE square tau by M. Okay? Shibu subscribed and liked. Very good. Yeah? These are all direct questions, students. You're just substituting formulas here and there. That's all. Okay. Next question. Deduce the expression for an equivalent EMF and internal resistance of two cells connected in series. Okay. So what is happening here? You have two cells that are connected in series. Okay. So the first cell is E1, second cell is E2. The first cell has a resistance R1, second cell has a resistance R2. Okay. So the total EMF will be what? E1 plus E2. Since they are in series, the total internal resistance will be R1 plus R2. Do you all agree? Two cells are in series. So R1 plus R2. Now, if this is connected to a load, okay, this is connected to another resistor. This whole thing is connected to a resistor. So the total resistance of the circuit, since this is all in series, will be R plus R1 plus R2. Three resistances are there. So R plus R1 plus R2. Okay. Now, very famous Ohm's law, we know that I is equal to V by R. Now, here, what is the total voltage? It's basically E1 plus E2. What is E1 plus E2? E equivalent. Divided by total resistance is what? R plus R1 plus R2, which is basically R plus R equivalent. Now, here I have expanded it. E equivalent is E1 plus E2, R plus R1 plus R2. So from this equation directly you get E equivalent is E1 plus E2, R equivalent is R1 plus R2. Okay. So what will the current be? Same formula. This is the final answer. Final answer. Yes. Yadav, at least some questions from this will definitely come. Okay. Because in every year, at least some of these questions have been asked. I wouldn't say all will come. I don't want to lie to you. Okay. But some of the questions from this will definitely come. You can trust me with that. Yeah? Okay. Nitin Kumar, what do you want to know in Hindi? Okay. Done. Very easy question. Okay. Next question. Derive an expression for equivalent EMF and internal resistance of two cells connected in parallel. One second, I lost the live chat. Okay, two cells connected in parallel. Yeah. Yeah. How do you get that? So here you need to have two cells, one cell and the second cell, they're connected in parallel. Okay. So they're connected in a parallel circuit. So we have to find out the equivalent current through them. Okay. So what we're going to do, we're going to use Kirchhoff's law. So what is Kirchhoff's law states that? Kirchhoff's law says that V is equal to IR1 plus I2R2. How many ever are there? All of those together. So the total voltage or the total EMF in a circuit is the total currents into the total resistances. Okay. So what we're going to do for E1. First we're going to take for E1. Okay. So for E1, what all are there? E1 has a current of I1 passing through it and an internal resistance of R1. Okay. Okay. I1, R1 plus IR is the extra resistance connected to it. Similarly, E2 will be I2 is the current flowing through R2, R current flowing through E2, R2 is the resistance through R2 plus IR. Now, both the equations, if you rearrange in terms of I1, you will get these two. Okay, so equation 1 and equation 2 you rearrange, so you will get I1 and I2. So total current is what? I1 plus I2. Yeah, total current I is equal to I1 plus I2. It's basic math. Okay, I'm just adding 1 and 2. I've put all the steps here. Students, take 5 minutes, okay, and go through these steps. Just basic math. Okay, so what I've done is I've added I1 and I2. So I take all the common terms out. Okay, I take the common terms out, do cross multiplication I have added. I will get this answer. Okay. Now, from this equation, I get this. I can be written as E equivalent by R plus R equivalent, where E equivalent I write it as E1 by R1 plus E2 by R2, and then R equivalent similarly. Alright? Okay, next question. Obtain the condition for balance of Weiston's bridge using Kirchhoff's laws. Students, for whichever question I've put diagram, if you don't draw a diagram in your answer, you will not get marks. So please make sure you draw these diagrams also. Okay, that's why I have put these diagrams. All right. Okay. Okay. So, students, listen to me carefully. I'll explain Kirchhoff's laws. Yeah, carefully. Obtain the condition for balance condition. Obtain the balancing condition for a Weiston's network using Kirchhoff's law. So I'm going to start from this point. Okay. Yellow is a color that you can't see. Let me take purple. Okay. I'm going to start from this point. Okay. So from here, there's a current I1 passing this way, I2 passing this way. It's written here. Okay. I'll show you like this. I1 that way, I2 this way. Okay. And then this I1 goes, IG goes this way. Okay. So what goes this way? I1, IG goes this way. So what remains? I1 minus IG is on this path. Okay. So I1 goes, IG goes. Here I1 minus IG. Similarly, second path. I2 comes like this. IG comes like this. So here what is there? I2 plus IG goes on this arm. Okay. So this is the Weiston's network. So if you look at the whole circuit, you can see here. So make sure you take a sign convention. So when you start from point A, I am going to assume that from point A, when I am moving in this direction, any current that is going along the direction in which I am going is going to be negative. That I am deciding. You can take it the other way also. Okay. So this is point A. From here, if I go this way and I1 is also going this way, then I1 is negative. But if current is coming this way and I am going this way, then I take it as positive. Okay, that is my sign convention. So I'm going to start from point A. Okay, so from point A, as I'm going to point B, from A to B, there is a current I1P, but it's going along my direction. So I put it as minus I1P. So I1 is current, P is resistance. Okay, V is IR. So here I and P is my resistance, minus I1P. And then I'm coming down. Okay, I'm going from A, go to B. From B to D, I am coming down. IG is also coming down. So it says minus IGG. Ig is the current, G is the resistance of the galvanometer. And then I have come from A to B to D. Now I'm going back to A. So when I'm going to A, I am going from D to A. Students, please look at the figure and what I'm explaining, okay? I am going from D to A. I2 is coming in the opposite direction. So I2 will be positive. What is the resistance there? R. So it will be I2 R. Now this whole thing will be 0. Kirchhoff's law, one whole loop will have 0. Okay. Same thing I'm going to do for the second loop. The loop BDC. Okay. Same thing I'm going to loop BDC. Okay. Same thing I'm going to do with the loop BDC. What am I going to do? Yeah, I'll start from point B. Okay. So from point B, I'm going to C. So I1 minus Ig is along the same line. So it will be minus I1 minus Ig into the resistor there is Q. Now I'm going from C to D. C to D, the current is in the opposite direction. Current is from D to C. I am going from C to D. So it's positive. Plus I2G into S. Then I'm going from D to B. But galvanometer current is this way. So it's opposite. Again plus I1 minus Ig plus G. Okay. So if you get this much, then the rest is sorted. The rest you can figure out. Okay. So those who didn't understand, play this video in 0.5 or some speed. Draw the diagram in your book. Look at the diagram and listen to my audio. It will be crystal clear to you. Okay. And then Ig is 0. See, when this Wheatstone's bridge is balanced, galvanometer does not show any deflection. So Ig will be 0. So all the Igs you can make it 0. So now what are my equations? This and this. And then I'm going to divide these equations. I'll get P by Q is R by S. In some books it will be R2 by R3 equals R1 by R2 and all that. Okay? Okay. Yeah. Next is from moving charges and magnetism. This is a very important derivation, students. Expression for magnetic field at a point on the axis of a circular current loop. You will get this derivation for sure in either your midterm or your end term. Okay, any one exam will definitely have this derivation. This is a very important derivation. Okay, so for this derivation also, students, diagram very important, and diagram is very easy. Okay, I'll teach you how. Okay, I'll tell you what the diagram is. So you have a circular loop. Okay, you have a circular loop. This is a current carrying wire. Okay, this is the axis. Okay, an imaginary axis I'm taking. There's a current carrying wire. I am going to find out the magnetic field at point P from the current carrying wire. Okay. So I'm going to take a random point on the current carrying wire. Let's say I take this point and I draw a line all the way to P. Okay. So here I'm going to take a small element. I will write it as DL. Okay. A small element DL. Yeah. I take a point P which is far away from a current carrying wire, and I am going to find out the magnetic field at point P because of this current carrying wire. Yes, do you all know that every current carrying wire will have a magnetic field around it? So I have this current carrying wire. I am going to find the magnetic field at point P. Now this point P is at a distance R to my current carrying wire. It's at a distance X to the center of the wire. Okay. Now, this is the direction in which my magnetic field will be. It will be in a random direction. Okay, now if I take a point here at the bottom of the wire, which is also at a distance R, then the magnetic field will be in dB direction. So since these two magnetic fields are in random directions, I am going to resolve it into horizontal component and vertical component. Okay, so if this is theta, every time I've taught you so many times, the angle, the line close to the angle is cos theta. The line away from the angle is sin theta. So this will be dB cos theta. This will be dB sin theta. Same thing for this one also. For this one, there's dB cos theta, dB sin theta. For this one also, there's dB cos theta, dB sin theta. So here also you have dB sin theta. And then one more dB cos theta. So, okay, this is the figure. Yeah. Now, same thing I have here. So I'm going to show from this figure. So you can see here, there's one dB sin theta in the up direction and one in the downward direction. So since they're equal and opposite, they will just cancel out. Okay, both the dB sin thetas will cancel out. So because of the horizontal current, because of the current carrying loop, point P will experience a magnetic field only in the cos theta direction, which is only along the x direction, because along the y it will cancel out. So it will be only in the x direction. That is why here it's written dbx is db cos theta. That's the only magnetic field the loop experiences. Okay, that's the only magnetic field the loop will experience. And you start by writing Biot-Savart's law. dB is equal to all that Biot-Savart's law you write, and then you will find out R using Pythagoras theorem. So what will R be? Hypotenuse square is equal to R square plus X square. Pythagoras theorem. And then cos theta you find out. Okay, cos theta is what? Adjacent side by hypotenuse. Okay, so this is, if you take this as theta, the adjacent side by hypotenuse will be x by r. And then all this you substitute in the formula. That's all that you should do. Okay. So what I'm going to do is, I find out this much, then what I will write? I'll write dbx is equal to db cos theta. Now what is db? Equation 1. From equation 1, I'll substitute db. From equation 2, I'll substitute cos theta. That is written here. This is db. This is cos theta. X by r is cos theta. And then what I'm going to do, I'm going to integrate. Okay. I'm going to integrate over the whole thing. Okay. So integral of dl is going to be 2 pi r. That's because this is a spherical loop. Okay. So the total length, dl is a small length element, but if I integrate it for the whole thing, it's going to be 2 pi r. Okay. And then I substitute, I will get the answer. Simply, you just have to rearrange and all that stuff. Okay. So I want you to carefully go through this. You will understand for sure. Okay. You can have my word there. Listen to my audio as well and look at the figure and the derivation. You will definitely understand. Okay. Next question. I don't think I'll have time to explain all the questions, but still we'll see. Derive the expression for magnetic field at a point inside a long current carrying solenoid by using Ampere's circuital law. Okay. Students, I will just, remove my head so you can see the whole derivation for a second. Okay. So here, this is the figure. You have a long solenoid. So you're going to take a small element from the solenoid. Okay. So from Ampere's circuital law, you will get that B dot dl is equal to nu 0 I. You've learned that. Now, this full rectangle has 4 paths. Okay. This is one path, second path, third path, fourth path. So the total integral B dot dl will be B dot dl for A to B, B to C, C to D and A to B. Okay. So all the perpendicular ones will be 0. See, all the ones that are perpendicular are going to be 0. So the only one remaining is AB. Okay. And that will be B dot dl will be B into L. Why did I write it as B into L? Because this dl, integral of dl, this is a straight line. So integral of dl will be L. So BL will be nu 0 Ni. And then you rearrange, you get the answer. Okay. Okay. Let's move on to the next question. Derive the expression for the force between two long straight parallel current carrying conductors and hence define an ampere. Okay. So you're going to consider two parallel conductors that are separated by a distance r. Okay. So two conducting wires that are separated by a distance r. I1 is the current through 1, I2 is the current through 1. Okay. So the magnetic field produced by conductor 1 will be nu 0 I by 2 pi. Magnetic field produced through the second one will also be nu 0 I by 2 pi R1. What is force? Force is I2 LBR, and then you substitute, you get the answer. I will remove my face from the screen once again so you can see the whole derivation. Okay. So the definition of ampere also you get it from here. Alright. Okay, good to go. Shall we move on to the next question? Okay, next question. Obtain the expression for torque acting on a rectangular current loop placed in a uniform magnetic field. Okay, yeah, I hope you've seen the question. Now I will appear. Okay, since I'm not, on a standing setup, I can't move out of the screen. Okay, that's why I'm doing this. Now some of you might ask, ma'am, why you're not on a standing setup? Because I don't have a standing setup. I take classes from my house. Okay. Yeah. Okay. So this is a loop. Yeah. The loop. So this loop is in a magnetic field. Okay. This loop is placed in a magnetic field. So this loop will experience a force. It will rotate in the magnetic field and align in the direction of magnetic field. Okay, so the area of the loop will be what? Side into side. It's a rectangle or a square. So it will be L into B. Force is what? ILB sine theta. Lorentz force, we've learned that. Yeah. Now torque is what? F cross B. You just substitute F. Okay. And then you will get torque is equal to NIAB sine theta. All the steps are there here. Okay, superb. Next question. Okay, I should disappear again because you'll have to see the whole question. Write with a neat label diagram, explain the working of a moving coil galvanometer or give the theory of a moving coil galvanometer. So, see, how does a moving coil galvanometer works? It has a rectangular coil. You see here, there's a coil and then there's a pointer connected to the coil. This pointer moves and that's how it works. Okay. Yeah. So when current flows through the coil produces a force which makes the pointer move. Okay. And the force, the rotating force is given by torque is equal to NAI AB. Okay. So the restoring torque will be K theta. And then you equate the two, restoring torque and torque, you equate it. So you will get NIAB equals K theta. So I is equal to K by NAB theta. Okay. Ma'am, now the midterm completed. It's okay, Shashi. Some of them have midterm tomorrow. Some of them have midterm next week. Okay, so all over Karnataka, different states have different timetable. That's why we're doing different videos. Okay, Shashi. End time everybody will have together, so we'll kill it together. Yeah. So stay subscribed. Okay, stay subscribed to the channel. Next question is from magnetism and matter. Mention any three properties of magnetic field lines. What are the properties? They form closed curves. They're always from north to south. They never intersect. All those things. Okay. State and explain Gauss law in magnetism. Write its significance. See, what does Gauss law say that magnetic flux through any closed surface is usually zero. That means magnetic monopoles can never exist. Yeah. So whatever magnetic field goes in, it comes out. It can never stay inside. Okay. Super. Derive expression for magnetic potential energy of a dipole placed in a uniform magnetic field. So let's consider a magnetic dipole of magnetic moment M, which is placed in a uniform magnetic field B, which makes an angle theta. Okay. So the torque acting on the dipole will be, torque we already know is how much? MB sine theta. Okay. Now this will rotate from theta 1 to theta 2. So work done will be theta 1 to theta 2, MB sine theta d theta. So MB is minus cos theta, theta 1 to theta 2. So U is equal to minus MB cos theta, which is minus M dot U. Okay. Yes. Okay. Next, list any three properties of diamagnetic material. Weakly repelled by magnetic field, have relative permeability less than 1. Their magnetic properties are independent of temperature. Okay. So they're all independent of temperature. Mention any three properties of students from this chapter. You won't get a lot of 5-mark questions. It's mainly 2 and 3. Okay. So from the first chapters is where you get 5-mark questions. And then the chapter after this also. But this chapter, not a lot of 5-mark questions you will get. I don't think you'll get any 5-mark questions. Okay. Yeah. Write any three properties of paramagnetic materials. They're weakly attracted by a magnetic field. They're small. They have a small magnetic susceptibility. And their magnetic properties decrease with increase in temperature. Okay. Next question, ferro. Anyone they can ask. Para, dia or ferro, anyone they can ask. So ferromagnetic materials, they're strongly attracted by a magnetic field and that they can be permanently magnetized. Okay. So they have a very high and positive susceptibility and their relative permeability is greater than 1. Okay. So they exhibit the hysteresis and their magnetic properties will slightly decrease above Curie temperature. Okay, next chapter, electromagnetic induction. In electromagnetic induction, very few 5-mark questions are there. It's also mainly 2 and 3. But this is a 5-mark question you can get. They can ask you what's an AC generator, what's the principle behind AC, and derive expression for instantaneous EMF generated in an AC generator. In an AC generator. Okay, so what is an AC generator? AC generator converts mechanical energy into electrical. So there's a coil Okay, this coil will rotate and that rotation cuts magnetic field and that is going to give you electrical energy. Okay, so generator generates electricity. Yeah, so mechanical energy is converted into electrical energy. So what's the principle behind AC generator? It's very easy. I'll show you the picture of an AC generator, then it will be a little more easy for you. Okay, so you can see there's a coil. Okay, can you see this coil? So this coil is placed between a magnetic field. So when this coil rotates, okay, so when this coil rotates, what happens? The magnetic field is continuously cut. Okay, so this cutting of magnetic field will produce an EMF. Okay, so students, this diagram you don't have to draw a battery. Okay, you don't have to draw that because that is for a motor. All right, so this coil continuously rotates and it generates electricity. Okay, now derive an expression for instantaneous EMF generated in an AC generator. How will you do that? You just have to do d phi total by dt. Okay, so imagine the coil rotates with a constant angular velocity omega in a uniform magnetic field B, and at time t, the normal to the coil will make an angle theta, which is omega t. Okay, and yeah, everything else is written here. You can just go through this. I want to do it. Next is alternating current. From alternating current, you will get 5 markers. Okay. But from the next chapter, from 8th chapter also, you won't get a lot of 5 markers. So first chapters and then alternating current. These are the major chapters that, you have high weightage questions coming. Okay. So make sure you finish those. But the next chapter is a very easy chapter. So don't skip that also because you will get 2 marks and 3 marks that you can easily answer. Okay, next question. Obtain expression for current in case of AC applied to an inductor. Show that current lags behind the voltage by pi by 2. Draw the phasor diagram and voltage current waveforms. I think a lot of you don't like this chapter, but this is a very easy chapter. I don't have the time right now to explain this chapter in detail, but I'll definitely do a video on that which will help you for your enter. Okay, so right now what you can do is you can learn that the EMF. Okay, the battery that you have connected, the EMF is given by E naught sine omega t. Okay, and EMF should also be equal to L di by dt. And then you say these two are equal. So if these two are equal, you will get this L di by dt is equal to basically L di by dt is equal to E naught sine omega t. So this L you take it to the other side. That is what I have here. Okay. Now, di by dt can be written as I. So, what happened? I integrated the whole thing. Integral of sine theta is cos theta. So, I will be minus epsilon naught by omega L cos omega t plus C. Okay. Okay. Yes. Happy? So, that question is not over. You have to draw the phasor diagram. How will you draw phasor diagram? First one will start. The second one will be with a small lag. Okay. So these are the phasor diagrams. I'll remove myself from the screen once again so you can see the whole thing. Alright. So I is epsilon naught omega L and you can just learn these two equations. Okay. Yeah. Good to go. Okay. Next question. Derive the expression for current in case AC is applied to a capacitor. Show that current leads voltage by pi by 2. Draw the phasor diagram. So here current is leading. So you start by charge. So you start by the formula Q is equal to C epsilon naught. Okay. Which is basically sine omega t. Yeah. Okay. And I is dq by dt. So you differentiate dq. What is q? C epsilon naught sine omega t. So what is the differential integral of sine omega t? Cos omega t into omega. Okay, differential, sorry. Cos omega t into omega. And then you get this answer. Okay. Phasor diagram also important. So when you draw it, one you start from here, the other one you start from here. So there's a phase difference. Okay. Next question. I think it should disappear again. Yeah. Derive the expression for impedance and hence current of an RLC circuit, series circuit connected to an AC source using a phasor diagram. Okay. So these parts, using a phasor diagram. Students, I don't know if you would learn these chapters. I heard a lot of students skip these chapter, but then please wait. Don't skip the video. The next chapter is very easy. I'm going to share some questions from the next chapter also. Okay, so please don't move out. Skip out. Wait till the end of the video. You might like fast forward, no? Okay, whatever. So here, what we're going to do, we have voltage across resistor is in phase with current. So VR is IR. But voltage across inductor, it leads by 90 degree. Voltage across capacitor lags by 90 degree. Okay, so this is how the diagram will be. One is leading, one is lagging, one is behind. Okay, so if you want to find out the net voltage, what you should do is you should take V is equal to square root of IR square plus VL minus VC the whole square. Okay, which is going to be equal to I times R square plus omega L minus 1 by omega C the whole square. Okay, so Z equals R square plus omega L minus 1 by omega C. Okay. So yeah. Now let's move on to the next chapter. Electromagnetic waves, very easy, students. You will not get 5 marks. Okay, don't worry. There are no 5-mark questions from electromagnetic waves. Even if you get them, it will be very easy 5 marks. No derivation type 5 marks from electromagnetic waves. Okay. Hema, the question paper won't be the same, okay? Even if another district student sends you the question paper, it's not going to be the same, but you'll get similar questions. I have shared a question paper. You can just watch my video, where I've done a sample paper. That's a question paper from another district, okay? So you can try to do that. So you will get questions similar to that maybe, okay? So you refer that video also. A sample paper, prediction paper we have done for all subjects. So please make sure you watch that video also before your exam. Okay, now from electromagnetic waves, first question. Write the expression for displacement current and explain the terms. What is displacement current? Displacement current is basically the rate of change of flux. So how is it given? So ID displacement current is epsilon naught d phi E by dt. Okay, epsilon naught is the permittivity of free space and phi is the electric flux. So it acts like real current in producing magnetic field in regions where conduction current is absent. Hi, Sharon. Welcome to the session. Yeah. How many of you are scared for tomorrow's exam? Put some fire emojis. Let's just burn your fear. Yeah. Put some fire emojis and burn your fear. Okay. Next is Ampere's Maxwell equation and explanation. Okay, so if you're asked for the Ampere-Maxwell equation, okay. Hema, if you learn, you will definitely get some marks. Okay, I can't tell you correctly how much, but I've explained most of the important 5 markers. So if 5 markers are sorted, you get a lot of marks. Yeah, these are all important questions. Okay, yeah, next question. Ampere's Maxwell states that where H is a magnetic field, J is conduction current, density, blah, 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 This is just a 2-mark question. You might get 2 marks for this. Okay. Okay, next question. What is displacement current? Write the expression for speed of light in vacuum in terms of permittivity and permeability. So displacement current is mainly due to changing electric field. Okay, and it is not due to the flow of actual current. It maintains a current flow in capacitors. Yeah, and what is the formula? ID equals epsilon naught d phi E by dt. The speed of light in vacuum is related to permittivity by C is equal to 1 by square root of nu naught epsilon. Okay, so the next question, 2 properties of electromagnetic waves. So electromagnetic waves are transverse with mutually perpendicular electric and magnetic fields. They can travel through vacuum with the speed of light, blah, blah, blah. From this chapter, you can get other questions which I have not included here. So they can ask you applications and properties of all the electromagnetic waves. So they can ask you radio wave, gamma wave, X-ray, microwave. So make sure you learn the applications and properties of all of these waves. Okay, they might ask you in MCQs, they can ask you, give the radiation which has the highest wavelength. Okay, or give the radiation which has the lowest frequency. So it's important for you to learn that order also. The order where you have, all of these, learn it in any one way, either in, increasing wavelength or increasing frequency. So the order is important. You have to learn about each one of them. Okay, how they, change and all that. One common thing you can write about all of those for radio, X-ray, gamma, whichever visible light is, they all travel with the same speed, which is the speed of light. So for all of them, if they're asking for similarities, you can write down the properties of electromagnetic waves. Because they're all electromagnetic waves, they will all have these two same properties. Okay, so even if they ask you radio or micro or X-ray or UV or what are they, gamma, whatever they ask, if they ask you two properties, you can write down these two. You can say they are electromagnetic waves, they are transverse, they have perpendicular electric and magnetic fields. They all travel with the same speed, which is the speed of light. Okay, understanding? So students, are these the only chapters that you have? See, everybody, your midterm portions are the same, no? 8 chapters. Yeah, because I got timetables from 2-3 districts and they all had 8 chapters. So can you please let me know in the chat if you all have 8 chapters? Yes, put 8 in the chat if you all have 8 chapters. All of you put 8 if you all have 8 chapters for your exam. Quickly. Okay, so in this class I've discussed some important questions. So these are questions that are seen every year. Okay, I've not discussed every question. Okay, I've not discussed the complete syllabus or lecture series or nothing like that. I have discussed important questions. Yeah, Lakshman and Hema, they have 8 chapters. Okay, Tanu also has 8 chapters. Super. Okay, so I will share this PDF immediately with you. All right, after 10 minutes you can check the description of this video. You have to join Vedantu Karnataka Telegram channel and then you will find the notes here. So make sure you sit and learn. Yeah, all of you have your midterm tomorrow, students. Hema, Lakshman, Tanu. You will pass, Hema. Don't worry. Do you all have your midterm tomorrow? So for those who have midterm next week, can you please let me know, because I'm planning to do numericals also. Yeah. So if all of your midterms are over, then there's no point of me doing numericals, right? Anybody in this chat who has new physics exam next week? Anybody has physics exam next week? You will pass, Hema. Don't worry. Yeah. Okay. Anything you want to ask? Tanu has physics exam next week. Yes. Anything that you want to ask me, students? Any doubts you have? Otherwise, I will wind up today's session and I'll meet you all with another fun video in the next class. So all of you, please subscribe to the channel, mark your attendance, hit the like button so we can give you wonderful content like this. Okay? Yeah? Okay? Okay, Lakshman has his exam tomorrow. His or hers. Very good. All the best, students. I don't want to waste your time, No, ma'am, tomorrow. Okay, Tanu also has it tomorrow. Okay. Anybody having midterm next week? All have tomorrow. Yeah. So all the best. I'll pray for all of you. Okay. So whatever you study, study properly. Write and study. Okay. Don't, try to study everything now. Whatever you study that properly. Because at least for that question, you'll get 5 out of 5. Yeah. If you study everything little, you'll get little marks for everything. But whatever question answer you study that properly. Okay. So whatever you write in your paper, you should get marks for that. Okay. This is for students who haven't studied anything. Those who are going to study last minute. Others, please do your revision. Keep doing well. Okay. For those who have not studied anything, whatever you study properly. Don't just study everything and forget everything. Okay. Whatever you study properly. Venkatesh has Tuesday onwards. Good, Venkatesh. So Saturday, Sunday, I'll be giving you a lot of content. Okay. I'll be giving you 31 important questions. I'll be giving you numericals and lots of content. Okay. Yeah. So I'll pray for all of you. All the best. Do well. So I'll see you all with another video. Bye-bye.